This is section 3.3, and this is a pretty packed section. There's 3 big ideas, and then there's a whole bunch of little ideas in the middle of it. And we'll come back to this just to generalize as we go through this section. So first thing we're going to talk about is a piecewise function, and it is like it says it is. It's pieces of a function. And if you look at this first one here, I'm just going to put that on here. Pieces or parts of graphs in our case. So I'm gonna write on here, and you want to do all of the notation that I'm doing because everything is worth points on here. So maybe you don't end up getting the graph right on a test, but you have all of your other information on here so that I know you know something, and you'll get points for something. But if you don't show anything and you've got your graph wrong, you're going to lose a lot of points on this problem. So the first thing I want to acknowledge is that this here is a line, and this here is a parabola. And this line is going to be all the x's that are less than 2. So g of x equals this line if x is less than 2. So we know that it starts at 2. Even though it doesn't include it, it's going to be an open circle. It's going to be 2 and all the numbers less than 2. So I'm going to pick another point. Each one of these has to have 2 points because we need to know where the 2 points are in order to draw the line or the part of a line. So this line is going to go from 2 to negative infinity, basically. And it's going to go there. So if I plugged in the 2, I'm going to have 14 minus 1, which is 13. And if I plugged in a 0, I'm going to have 0 minus 1, which is negative 1. And I'm going to do the tick marks on here. So at 0, it's going to be at negative 1. So here's one of my points. And at 2, it's going to be at 13, but it's going to be an open circle because it doesn't include the 2. It's just all the points less than 2. So this line would normally go all the way up, and you'd have arrows at the end. But I only want to see the part of the line that is from 2 to negative infinity. And that's what it's going to look like. That's the part of the line, the piece of the line that we're looking at. The second one is a parabola. And this is going to start at 2. And it's going to go greater than 2. So I'm going to just I pick 2. I always pick the boundary number there, just like I picked the boundary number there. And so I'm going to pick a bigger number than 2. I don't want to get too big, so I'm just going to pick 3. So 2 squared is 4. I'm dropping these in, and 3 squared is 9. And this is a parabola. We know that this parabola goes through 0, 0 if we saw it. And it's going to open up, so it's going to go like this. But I only want to see this part over here. So at 2, it's going to be at 4. 1, 2, 3, 4. And it's going to include it. And then at 3, it's going to be at 9. 5, 6, 7, 8, 9. So it's going to go through that. And we know it's going to come through here, but we're not going to draw that part. We're only going to draw that part right there. And I need to make sure that you know this is a curve. So be really careful that you're showing that on your graph. It doesn't look like a straight line to me. This should have an arrow because it keeps going to the left, just like this one has an arrow. But it has a point there, so it has an end point and it continues on, an end point and it continues on. So I would call this here, this 2, 3 is my left. Actually 2, 13, that's going to be my right boundary for this one. And this 2, 4 is going to be my left boundary for this one. So definitely always have 2 points on these. Now let's talk about the domain for a second. So the domain is x and y, right? We've already talked about this. This keeps going to the left. So the left side is from negative infinity. And if you keep going here, if you look at the number 2, it does have a point. It doesn't have a point there, but it does there. So it keeps going, and it keeps going to positive infinity. The range also, it keeps going negative, so negative infinity, and then it keeps going up, and notice there's no break in here. Where the 13 doesn't count in the green, it counts in the blue. So this goes all the way to infinity. So let's take a look at these points here. So if I have f of 0, I have to think x is 0, so I have to use this one right here because x is less than 2, and if I plugged in a 0, I'm going to get -1. If my x was 3, I'm going to have to use the second equation because that's where the x's are greater than or equal to 2. And if I plugged in 3 there, that's going to be 9. And then f equals 2 is going to go into this equation because this includes the 2, this doesn't include the 2. So that's going to be 2 squared, which is 4. So you got to be careful which one is the correct equation that you want to put it into. Here's another piecewise function. So again, you want to make sure you're marking these. So we know this is a line and this is a line. And we need 2 points here and 2 points here. And this one is going to be less than or equal to -1. So it's going to go from -1 to less than -1. This one starts at -1 and it goes to the right or greater than. So I'm going to use 0. So I picked these points all by myself. I just keep them close to the ones that are here. I don't want them to get so big or so small that my graph is a lot of work. So if I plugged in a -2 into this equation here, that'd be -4 minus 1, which is -5. And if I plugged in a -1, that's -2 minus 1, which is -3. I'm going to do the same here. -4 plus 3 is -1. And 0 plus 3 is 3. So here's my points. I know these are parts of lines. So I'm going to just mark that. That's going to be the red one over here. So I'm going to start at -2, -5 as my first point here. Actually, I'm going to start at the -1. So -1, -3, and this is going to include it. And then at -2, -5. So this is going to go down like this. So it's going from x equals -1 to -infinity. So it's going to keep going this way. The second one, I'll mark it green. My left bound on this one is -1, -1, and it's not going to include it. So it's going to be an open circle because of that. And then my next one is 0, 3. That's going to be right there. And again, that is a line. So I want to make sure that looks like a line. Let's talk about our domain and range on these. So the domain are the x's, and I just want to point out here that on the x's, notice that this here, for the x's, it includes it because the red one is including the -1 even though the green one isn't. So this is going to go from -infinity to infinity. The range is a little different. So as the y's, notice there's a gap in the y's here. And so this is going to go from -infinity all the way up to this red here, which is 3, and it includes the 3. And then there's another group that starts at -1 but doesn't include -1, and it keeps going up to infinity. So this range is a little different. So let's take a look at this one. Again, these are both lines on these. And if I'm looking at these ones, this one starts at 4 and it goes to the right. So I'm going to go 4, and then I'm going to pick another number, maybe a 5. So if I plug in a 4 in this, that's going to make a 0 for a y. If I plug in a 5 for this, that's going to make the y a 1. I'm going to do the same for here, except this one, if I think about the number line, it's going to start at 4 and it's going to be less than 4. And I could use 3 as my other one. I know they're lines, so I just need 2 points. So 4 minus 4 is 0. 4 minus 3 is 1. So those are my 2 points there. And then I'm going to go ahead and graph this. So if I were to graph the top one here, that's going to be a line starting at 4 and going to the right. So 1, 2, 3, 4, 0, 5, 1. And I made a mistake here because this should be an open circle because it doesn't include the 4. And it's going to go to the right. If it helps to draw the arrow there, draw it. That helps you then. And then the second one is a line. It's going to start at 4 and it's going to go to the left. So at 4, it's going to be 4, 0. Fill that in with green. And 3, 1. And it's going to be a line going to the left. So if these arrows help you, it'd be good to draw them. What are some examples where you are charged a certain rate on something for a period of time and then the rate changes based off of time or usage? And I have some examples. If we were in class, we would go through them. One thing would be phone plan. It used to be when you were texting, you had, let's say, 0 to 100 texts might cost $10 a month. If you had 101 to 200, maybe that was $15 a month. So where it had certain ranges that the price stayed the same. Another one would be college tuition. This didn't used to be this way. But now if you have 12 credits or higher, you're going to pay a certain dollar amount. So whether you have 12, 13, 14, 15, all the way up to 18, that's full time. And part-time might be 10 to 12 credits, and that's going to be another certain amount of money. Parking meter are also ranges. Service calls. So a service call, it might cost you $100 to get someone to come in and fix your air conditioner, and then it's so much per minute after that. But there's a minimum on there. So it could be $100 for the first 60 minutes. Whether they're there 1 minute or 60 minutes, you're going to pay the same price. Another one would be baggage when you're flying. So 0 to 50 pounds is free. So anywhere in that range. And then if you're above 50 pounds, it's going to cost you money. Stamps at a post office. Your letter could be 0 ounces up to however many ounces is going to be a certain price for a stamp. So those are different ranges of values for a certain price. And those are called step functions. So it is a type of piecewise function, but they look like steps. So if you take a look at this first one here of the f of x, we know f of x equals 20 is a horizontal line. All of these are horizontal lines. Equals 30, equals 40. But it's only going to go, this first one here at 20 is only going to go from 0 to 5. So on this one, we have 2 boundaries. The other ones that we've looked at, we only had 1 boundary. So when we do our ordered pairs here, which we wouldn't necessarily need to do on horizontal lines, so we have y equals 20, 30, and 40. And this is going to go all the way to 11. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And at 20, it's going to be a horizontal line from 0, including 0, all the way to 1, 2, 3, 4, 5. Not including 5, so that's the part of the horizontal line. The second one is going to be at 30, and it's going to include 5. And it's going to go to 6, 7, 8, but not include 8. And then the third one is going to be at 40, and it's going to include 8, but not include 11. So that's the step function of these 3 horizontal partial lines. So if you think about the domain on this one, the domain is going to go from 20. It's going to include 5 because the blue takes care of that. It's going to include 8 because the purple takes care of that. And it's going to go to 11. So it's going to go from 0 to 11. And it's going to include the 0, but not include the 11. The domain or the range has a 20, a 30, and a 40 only. So it's going to be 20, 30, 40. So if I go ahead and look at the f of x's here, so if I look at the first one, f of 9, the 9 is going to be in this range right here. So f of 9 is going to be 40. f of 5, the 5 is going to be here because this one includes a 5, so f of 5 is going to be 30. And f of 8 is going to be down here because this includes the 8, which is going to be 40. Another type of function is the greatest integer function. You probably haven't seen this one before, but it's an integer, looks like this, where this greatest integer function equals the greatest integer less than or equal to x. So if you take a look at the greatest integer less than or equal to 0.6, so if you think of where 0.6 is on the number line, it's going to be right here. So the greatest integer less than or equal x is going to be 0. If I had the number 6 here, 6.7 is going to be right here. The greatest integer less than or equal to 6.7 is 6. The greatest integer, this would be 4, negative 4 and negative 5. So the greatest integer less than or equal to 4.8, which is right here, is going to be negative 5. 6, the greatest integer less than or equal to 6 is 6. And then negative 2.1 is going to be right here. So the greatest integer less than or equal to negative 3 is, or negative 2.1 is negative 3. So you're just looking to the left of where the number is on the number line. So it's less than or equal to it. Here's the graph of a step function or a greatest integer function with the domain of negative 3 to 3. So if we're going to look at this one and graph it, and we're going to go from x being negative 3 to 3. So those are the parts that I want to do. So if I were to do this one, these are going to be the integers, right? So this is going to be negative 3. Let me just do this one. So negative 3, all the way to negative 2, not including it. So this is what this one looks like. And then the next one's going to go negative 2, all the way to negative 1, not including it. So this is negative 2. And then negative 1, all the way to 0, not including it. So this is negative 1. And then 0 to 1, this is going to be 0. Think about that. It's going to go, not including this one, but all the numbers in between here, all the way to that integer, greatest integer. And then we have 1 to 2. So this is 1. And then 2 to 3. And this is 2. And then the next one's going to be just 3 because it wants us to stop there. So we have to stay within that domain, otherwise we would keep going. So that's what this greatest integer function looks like. Next, we're dealing with is absolute values. This is a piecewise function, and this one here we are going to graph. Notice all the other ones we are graphing by hand. I'm going to just graph this by hand just so you can see the first one here, and then we're going to use the graphing calculator on the rest of these. So when x is 0, this would be 0, the absolute value of 0 is 0. When x is 1, this is 3, the absolute value of 3 is 3. When x is negative 1, the absolute value of negative 3 is always the positive, so that would be 3. So we have 0, 0, 1, 3, and negative 1, 3. And this is going to keep going. Oops. It's going to have arrows. It looks like a V. And we're going to graph these on the graphing calculator, so it'll be really clear on the test which ones you're going to be by hand, which are all the ones that I've done so far in this lesson, and which ones are going to be on the graphing calculator. So if you did this as y1 and y2, and I'm going to pull my graphing calculator up, you need to know where the absolute value is. That's how I'm going to know if you actually watch my video on this one, because there are students that in the past did not watch my videos and didn't know where the y or the absolute value was. So I'm going to go into here, I'm going to clear these out. And then I need to go back up here. So the absolute value is in the math button. It's a number, and then CABS. So if I put that in, and then I'm going to put inside of here x minus 3. And then the second one is 9. And I'm going to just do a zoom 6 to see those. And the value that makes this true will be where the red and the blue intersect. So I'm going to have to make this x a little bit bigger because I'm not seeing the other intersection there. So I'm going to go into my window. I'm going to make the x, maybe I make it 20. Just to slide that over a little bit more. And then I'm going to do just like I did in the last chapter, just like I've done all along, is find the intersections here. So you should be pretty good at doing that now. So I'm going to calculate the intersection, and I'm going to just slide it over so it hovers around this one to the right since it's almost over there. And I'm just going to push enter on all those. That's going to be 12, 9. And then I'm going to find the other intersection. So I just got to slide this way. And I can't hold my button down like you guys can. Okay, that's close enough. That's going to be negative 6, 9. So if I go back to here, so I have, this is what my graph looks like. And this is going to be, oops, let me go like this. So this is going to be negative 6, 9. And then this one is going to be 12, 9. And look at what it's asking you to solve this. So x equals negative 6 or 12. Looking at the next one here, so these are the easiest way to solve these ones by using your graphing calculator. So again, we're going to put that in our graphing calculator, knowing that this is going to be a V-shaped and knowing this is going to be a parabola opening up. So let's go ahead and put those in our graphing calculator and I'll work through those with you. So I'm going to clear both of these out. And I'm going to have the absolute value, so math, move over to number, enter. And that's going to be x minus 5, enter. And then x squared minus 5x. And I'm just going to do my zoom, oops, not zoom 3. I guess it will work. There's my absolute value part, and there's my parabola part, and I want to calculate the intersection. And I'm over by that one already, so let's just move that through. So that's 5, 0. And then I'm going to calculate the intersection of my other one. I just need to hover over that one. And that is negative 1, 6. So I'm going to go back to here and put these on here. And then that's going to loop down like that. Oops. I want it to be pretty good on my graph. Like, it's not going to be perfect, but you should have it pretty decent. So this one right here is going to be negative 1, 6, and this one right here is going to be 5, 0. So I'm answering my question. X equals negative 1, comma 5. That's my final answer. I think this is the last part, direct variation and indirect variation. So direct variation, you've seen this before. A linear of direct variation would look like this. Y equals kx, which is just to the first power. Quadratic would look like this. Y equals kx squared. K is the constant or the number that gives how x relates to y, what the relationship is between the two. That's different than the inverse variation. One of those would look like this, y equals k over x, or y equals k over square root of x, it could be, depending on how it relates to it. This one could be y equals k to the square root of x, or k times the square root of x, or y equals, I'm just giving you some examples of what we're going to be working with here, cubed. One more. Okay, so let's take a peek at these. Suppose that y varies directly as the square root of x. Let's just look at that part right there. So y varies directly as the square root of x, so the square root of x is going to go there. That's the first part. I want to see the work for that you knew that. If that's all you know, you're going to get something for this. And then it says that y equals 18 and x equals 9. So if y equals 18 and x equals 9, my next job is to find k. So how does x vary directly with k? What's the k, the multiple of? So this is going to be 18 equals k times 3, square root of 9 is 3. Then I'm going to divide both sides by 3, so k equals 6. So then I have my actual equation here, y equals 6 square root of x. So that's the equation that I'm working with. So basically I kind of found the slope, if you think of it that way, finding the m in a sense. And this is my equation. That's going to be worth a point right there. This is going to be worth a point on a test. And now I'm going to answer the question. Find x when y equals 24, if all this varies directly like this. So find x when y equals 24. So I'm going to divide by 6 to get 4. And then I'm going to square it, because that's how I get rid of a square root. So x is going to end up to be 16. So that's your next point. X can't be negative 16, because when you put it under square root, you can't have a negative under the square root. So there is varying directly. Here's one where you're varying, y varies inversely as a third power of x. So y varies inversely as a third power of x. So if you think of what that looks like, inversely means the k is on the top, and how it varies, this would be x to the third power. So there's your first point. Your second part of the problem is going to be find k. So y is 5 and x is negative 1. That's how you're going to find k. K over negative 1 cubed. So that is k over negative 1 times negative 1 times negative 1 is negative 1. Then I'm going to multiply by negative 1 to get k equals negative 5. So then I'm going to write my equation. Y equals negative 5 over x cubed. Now I'm going to answer the second part of this, the third part of this problem. What is y when x is 0.5? So I want to find y when x is 0.5 cubed. And y ends up to be negative 40. So again, I'm looking for this, I'm looking for this, and I'm looking for this. So this is the last screen that I want to go over on this one. So sketch a graph of these functions. So a linear just is a line, and a lot of you know how to do that already. X squared is going to be a parabola up or down. X to the fourth is similar to a parabola, except it's going to have some bumps in it. And x to the sixth will probably have some more bumps in it. It'll actually have 5 turning points. It's one less than the exponent if you look at that. A half power is going to look like this. It's going to be a half a parabola turned sideways. Could be steeper or flatter. A third power looks like this. A fifth power and a seventh power is still an odd power, so it might have some extra bumps in it. Might look like that. And then to the 1/3 power is going to look like this. So it's going to be sideways, basically, like that. And then a reciprocal function is, this is y equals 1 over x is the same as y to the x to the negative 1. And that's going to look like a hyperbola. And why is that? If you take a look at the x and the y, x could be 1, which gives y 1, but x cannot be 0, and actually y cannot be 0. So that's going to look like this. And we're going to go through some of these in much more detail later, but I just wanted to put those out there to you. This is your homework for this section. Again, be careful, do all the ones by hand that I did by hand in the notes. You should have those as examples for you to help you through them. And then when you get to the absolute value, you can do that with the calculator. So please follow how I did them in my notes in your homework so you'll be ready for the test.